So we'll roll through some the definition of complex system. Just reshare, and then we should be good to go. All right. So we a few more definitions I'll highlight quickly, but really the diagram on the right is the focus. We talked about system elements and how system elements comprise systems. And I already used the term system of interest, which is the specific focus of the SE effort. It's the system that we're concerned with or that we're designing in this in and then we have so we've covered those. The system context is the term that we use to define the environment in which the system operates. And then we have this idea of a system of systems where our overall system of interest could be comprised by multiple systems, which themselves are comprised of systems or system elements. So it is the recursive is probably the correct term, just in the sense of the system definition as we go down in decomposition level. And you can think back to the example of the light bulb that we used. Like at this bottom level, the light bulb is a system that's comprised of a few system elements, filament, etc. Then the headlight assembly that's using it, or just keep with the automotive. Sorry for that. The headlight assembly is itself a system that has a lens and a frame and mounting points. The headlight assembly goes onto the body, which is a system. The body is then comprises the car. So at one perspective, there's one system of interest, the automobile. Then at each of the subsequent layers in the decomposition, there's also systems that are themselves comprised of systems and components. And then an enabling system is anything that is outside of the system boundary or can be something. You don't have to have an enabling system, but if you have an enabling system, it's outside the system boundary that helps the life cycle stages, so like maintenance, but it may not necessarily contribute during direct operation. And we can see those, again, perspective is going to be uh, key for this. So if you have like active maintenance that's ongoing with your microgrid system as it's installed, that's and let's say active in that it acts on it every day, some type of cleaning, some type of monitoring, then it's maybe not even an enabling system. It is actually just an external that is always active within your system or influences your system. Whereas if you have like one-time installation, that's an enabling system, or transport to get your DER to the site, the transportation system is an enabling system that contributes to actually getting your system built up and installed. And you have to consider that. There's like examples of where either that has been missed or there's been certain design decisions that have had to be made. It's constrained things like space shuttle rocket booster sizes, some of the Airbus planes and different wind turbines are certain sizes because in the transportation phase from where either the subsystems are constructed or the full system, before the full system is built and ready to use, it has to meet certain limitations in terms of it has to fit under this bridge, or it has to go over this overpass with a certain amount of weight, or it has to be able to be transported on the back of a 747 in the case of the space shuttle. So key to consider the enabling systems and their limitations on how they influence your design.